राइट। अगर हम बात करें इलेक्ट्रिक करंट, राइट, सो इलेक्ट्रिक करंट I is equal to rate of flow of flow of charges, right? That is equal to I is equal Q upon T, and N is number of charges, E is one charge, and then time, right? So charge upon time is basically charge flowing per unit time. That is known as electric current, right? And electric potential, sorry, potential difference, potential difference, potential difference, yeah, potential difference is equal to V is equal to W upon Q, right? But the potential difference is work per unit charge, work work done per unit charge, right? And its unit is ampere, and electric current unit is ampere, and its unit is volt, right? And Ohm's law is that Ohm's law, yeah, at constant temperature, at constant temperature potential difference is directly proportional to work done, right? So V is directly proportional to I. If we remove this proportionality sign, then we will take a constant that is equal to R into I. V is equal to R into I, or we read more commonly, more frequently that V is equal to IR. Is it? Where R is resistance. Resistance is equal to resistance is R is equal to rho into L upon A, where its unit is ohm and resistance is obstruction offered by conductor in the flow of charges, right? This is what we have about RV, right? So further, should I rub this? Okay, so now when registers are arrangement of registers, when registers are arranged in series, This is ammeter, this is battery, voltmeter, and this is key. Right. If we have I current is flowing in the circuit and potential difference across the terminal of battery is V, this is R1, R2, R3, right? So V1 is equal to V1. Here potential difference will be V1. Here it is V2, and here it is V3. Fine. And so current, so V1 is equal to I into R1. Sorry, I into R1. I into R1, and V2 is equal to I into R2, and V3 is equal to I into R3, right? And sum of potential difference, all this V1, V2 is equal to potential difference of the battery, that is V is equal to V1 plus V2 plus V3. So we can say I into R is equal to I into R1 plus I into R2 plus I into R3, and I we have taken as a common, it becomes R1 plus R2 plus R3. I cancel, so R is equal to R1 plus R2 plus R3. So this is when resistors arranged in series, then potential difference, sorry, then resistance of circuit get increased, right? So total resistance of the circuit get increased. And in second case, if we are arranging these resistors in parallel, then resistance of circuit get increased. This is ammeter, this is battery, and this is key, right? This is when resistors arranged in parallel. So potential difference across the terminal of battery is V, and so potential difference across the terminals of resistors will also V. That remains same. And current I is flowing in the circuit when it enters, so it will go I1, I2, I3, and it will come out as a I. So sum of all is I, and this is R1, this is R2, this is R3, right? So I is equal to I in the circuit is equal to I1 plus I2 plus I3. So V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. So V we have taken as a common, so it becomes 1 plus R1 plus 1 upon R2 plus 1 upon R3. So this V and V is cancelled, so 1 upon R is equal to 1 upon R1 plus 1 upon R2, 1 upon R2 plus 1 upon R3. Getting? So net resistance in parallel arrangement, get decreased. So net resistance of circuit get decreased in parallel arrangement. Right? So this is what we have about arrangement of resistors. This is in resistors in series, right? And this is resistors in parallel. Fine. Okay. Now should I rub this? Now, as you know, power is equal to rate of work done. Right? So P is equal to W upon T, right? So it means work done, power is work done per unit time, right? It is in joules, it is in seconds, and it is in watt, right? So as you studied, V is equal to W upon Q, right? Yeah. बिल्कुल. Go ahead. Potential difference is equal to work done per unit charge. So V is equal to W upon Q. So W is equal to V into Q, right? Now putting this value in this equation, so we will get P is equal to V into Q upon T, right? And this Q upon T is I, right? So power is equal to VI, right? First, power is equal to Vi, and as we know, uh, from Ohm's law, from Ohm's law, you know, V is directly proportional. V is equal to IR, right? So put this value, or we can write it uh, V is equal to IR. So when we put in this value, so P is equal to Vi is equal to IR into I, it becomes I square R, right? So one more formula we get, P is equal to I square R. And if we write similarly, we can write it here like I is equal to V upon R, right? So if we take here P is equal to Vi, and now V is equal to IR, so V into V upon R is equal to V square upon R. So we can write it P is equal to V square upon R, right? Where V is potential difference. So now, now we get P is equal to Vi is equal to P is equal to I square R, or we can write P is equal to V square upon R. These are the formulas for power, right? Now, as you know, as I wrote here, P is equal to W upon T. So W is equal to P into T, right? So substituting the relevant values, we get W is equal to V I T, or we can write it, is I square RT is equal to V square R T, right? This is for work done. This is for work done, right? And here it is known as for electrical energy. Electrical energy, elect, electrical energy, electrical energy is equal to I square RT, ladke. I square RT. What are you going to talk about? No, this is I square RT we have, right? And we know that we know that uh, 1 kilowatt. If I write 1 kilowatt hour, 1 kilowatt hour is equal to 1000 watt into 3600 seconds, right? So it becomes, yeah, 3.6 into 10 raised to the power 6 watt second, right? This we have converted kilowatt hour is equal to 1000 watt, and hour is equal to 3600 seconds. So when you multiply this, then it becomes 3.6 into 10 raised to the power 6 watt seconds, right? So Yeah, that's why 1 kWh. So we can write it, you know, 1 kWh, 1 kWh is equal to 3.6 and into 10 raised to the power 6 watt per second, or we say it 3.6 in raised to the power 6 joule, right? This is 1 kilowatt hour, and this is known as one commercial unit. This is known as one commercial unit, right? This is we call one commercial unit. One commercial unit. Fine. I hope you understand all the formulas related to your electric current. So, hello. This question number 20. 120. A torch bulb when cold has a resistance of 2.5 ohm. It draws a current of 450 milliampere when connected to a 6-volt battery. um, battery. Calculate the resistance of the bulb when glowing and explain the reason for difference in resistance. Ah, 120. Question number 120. You want to start with 119, so why not with 118? This you know. I hope this is quite easy. You just want to start one. A wire has a resistance of 5 ohm. Calculate the resistance of wire of same potential material whose length is 3 times and area of cross section is 4 times of the first wire. Okay, good. Good. Should I rub this? This is question number 119. Fine. And question number 119 is saying there is a resistant wire. This is the wire. Resistance wire. Wire of 5 ohm. Length. Resistance of this wire AB. Resistance is equal to 5 ohm. Fine. And so initial length is L, and initial initial length initial length is equal to L, and cross sectional area is equal to A. So R is equal to rho into L upon A, right? R is equal to rho into L upon A. In that case, 5 is equal to rho L upon A. When so material of wire remains same. Material of wire remains same. So calculate the resistance same material whose length is 3 times. Now L dash becomes 3L, and cross sectional area and A dash is equal to 4 times, whose length becomes 3 times and cross sectional area becomes 4 times of the initial, right? So now resistance is equal to rho into L dash upon A dash, R dash. So it becomes R dash is equal to rho into 3 L dash upon 4 A dash. No. This is 3L and 4A. L dash is equal to 3L, so I wrote here 3L, and here it is A dash is equal to 4A, so I wrote here 4A. So R dash upon R is equal to rho into 3L upon 4A upon rho is equal to L upon A, right? So now we can write it here like this. This rho and rho is cancelled off, this L and L is gone, then A and A is gone, and this is, we have R dash, and resistance is 5, so I wrote here 5, and this goes down, so it becomes 3 upon 4, right? Three upon 4. So we will get it. So R dash is equal to 5 into 3 upon 4. It becomes 3 5s are 15 upon 4, is it? So 4 3s are 12, 4 7s are 28, 4 5s are. So this is resistance is equal to resistance of the wire becomes 3.75 ohm. It get reduced, right? Length increased and cross sectional area increased. When length is increased by 3 times and the cross sectional area increased by 4 times, then the resistance becomes reduced from 5 ohm to 3.75 ohm. This, you get this? Then should I go for next? So now a torch bulb when cooled has a resistance of 3, matlab initial resistance when current is not flowing. This is 120, question number 120. When current not flowing, when current not flowing, right? Bulb becomes cold, becomes cold, and resistance is equal to 2.5 ohm, right? And it draws a current, and I is flowing 450 milliampere. It means 450 into 10 raised to the power minus 3 ampere, and that becomes oh, 0.45 ampere, right? So now when connected to a 6-volt battery, what is written there in the last, when connect to a 6-volt battery, after that what is written? It is not clear in your picture which you sent me. Oh, okay. And now connected with a 6-volt battery, connected with a 6-volt battery, 6-volt battery, 6-volt battery, then you know V is equal to IR. So if 0.45 ampere is current and resistance is 2.5, then it becomes, potential difference is, calculate the resistance of the bulb when glowing. Resistance we have to find out of the bulb. So R is equal to V upon I. So resistance of bulb is equal to this much. So this is V is equal to 6 volt, and this is 45 0.45. We will remove this decimal. We will take 2 zeros here. It becomes 600 upon 45. So 15 fours are 0, and 15 fours are 60, and 0 15 threes are 45. It becomes 40 upon 3. So resistance is okay. So resistance of the bulb is 13.33 ohm, right? Four ones are 4, we get 10, 3 threes are 9, and keep on going. 9. This is the resistance. This is the resistance we have. So increase in resistance of bulb, increase in resistance of bulb due to increase on temperature 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 increase in temperature, increase in resistance of bulb due to increase in temperature, right? Got it? Okay, now should I remove this? Question number: a uniform wire with a resistance of 32 ohm is divided into 4 equal parts and they are joined in parallel. Okay. Should I rub this? Hello. Should I rub this? Okay, anyway. So now we have, you know, question number 121. Question number 121. There is a wire. There is a wire of 32 ohm. Total resistance of wire. Total resistance is equal to 32 ohm. And it is divided in 4 equal parts. It is divided in 4 equal parts. So this is 1, this is 2, this is 3. No, it's not seems to be equal, man. If I put it here, then the next one is so each, it is 4 equal parts divided in 4 equal parts, divided with divided in in 4 equal parts. 4 equal parts. So each will have 8 ohm, 8 ohm. So what I have did, 32 divided by 4 becomes 8 ohm. So each wire of will have a length, will have a resistance of 8 ohm. And when they are arranged in series, now earlier they were in parallel. Earlier they behave like arranged in series. Huh? Yeah. Say earlier they behave like arranged in series, and now on joining in parallel. Now joining in parallel, so it will be like this. Each is having a resistance of 8 ohm, 8 ohm, 8 ohm, 8 ohm. Then net resistance will be, then net resistance will be 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. So we can say that 1 upon R is equal to 1 upon 8 plus 1 upon 8 plus 1 upon 8 plus 1 upon 8. So 8 we have taken as a common, and 1 plus 1 plus 1 plus 1. So it becomes 4 upon 8. So 1 upon R. So R is equal to, net resistance R is equal to 2 ohm. So net resistance R is equal to 8 upon 4 becomes 2 ohm. Ready? So net resistance R is equal to 2 ohm. Right? Okay. So where can we come to next question, that is 122. Should I rub this? Oh. Now question number 122. Right? So this is point P. Six ohm, 4 ohm, 8 ohm, and X ohm. Very nice. Oh, so calculate the value of X if the equivalent resistance between the point P and Q shown in the figure is 5 ohm. So net resistance of the circuit, net resistance of circuit is equal to 5 ohm. Right? Net resistance of circuit is equal to 5 ohm. So here they are in series. Here in series. So our net resistance is equal to 6 plus 4 becomes 10 ohm. Right? And here they are also in series. sorry, here they are also in series, so net resistance is equal to 8 plus X ohm, right? And now they are in parallels. In parallel, so 1 upon R is equal to 1 upon R dash is equal, plus 1 upon R double dash. So we can write it, 1 upon 5, 1 upon 5 is equal to 1 upon 10 plus 1 upon 8 plus X. Fine. Bring this on the other side. So 1 upon 5 minus 1 upon 10 is equal to 1 upon 8 plus X. So we will take 10 as an LCM. 5 2s are 1s are is equal to 1 upon 8 plus X. So it becomes 1 upon 10. Now on cross multiplying, 1 upon 10 is equal to 1 upon 8 plus X. Cross multiplied, so 8 plus X is equal to 10. So X is equal to 10 minus 8 is equal to 2 ohm, right? So value of X, is equal to 2 ohm. Getting? Yeah, done? Okay. This was question number 122. So what next we have? You have so now question number 123, right? Question number 123 is like that. Question number 123 is like that. You have three resistance of R ohm and each and a battery of E volt. There are three resistors of R ohm. Okay, three resistors are of R ohm three resistors of R ohm each and battery E volt and battery E volt. How would you connect these resistors with a battery to obtain maximum current? Okay. To get maximum current, maximum current in circuit uh, oh maximum electric current in circuit, we must we must keep resistance minimum minimum. To get maximum electric current in circuit, we must keep resistance minimum, and that we can get we can get we can get only when arranged in parallel, right? So these three resistors these three resistors right, and there is potential difference is E volt potential difference, and they are having each is having R ohm resistance. So net resistance 1 upon capital R is equal to 1 upon small r plus 1 upon small r plus 1 upon small r. So it becomes 3 upon R, 3 upon R. So net resistance is equal to small r by 3, right? So this is the resistance. This is, this is the net resistance of the circuit, and this is the potential difference. So I is equal to V upon R. So it becomes E upon R upon 3. So we can write it I is equal to 3E upon small r. Getting? I hope you get this. Okay. So as when registers are kept in parallel, when registers are kept in parallel, then we get the minimum resistance in the circuit, and that's why we have arranged the resistors here in parallel, and potential difference is E. So current in the circuit will be like this. So I is equal to this much. So I is equal to 3 E upon small r. That's it. So, thank you.